Welcome back. We want to try and squeeze a lot of things in this last few minutes of our lesson. Let's still look at nitrogen-based fertilizers, and one other nitrogen-based fertilizer is ammonium nitrate. This is produced by reacting ammonia with nitric acid, okay? And nitric acid is produced through a process called Ostwald process, all right? And here is how the process unfolds. Ammonia reacts with oxygen to produce nitrogen monoxide. And the nitrogen monoxide reacts with oxygen to produce nitrogen dioxide. And from nitrogen dioxide, we dissolve that in water, we have nitric acid. So that is basically what the Ostwald process is all about. Now, another nitrogen-based fertilizer is ammonium sulfate. How is this one produced? It's produced when ammonia reacts with sulfuric acid, okay? And sulfuric acid is produced through a process called contact. It's contact process. Now, step one in the contact process, sulfur reacts with oxygen to give us sulfur dioxide. Step two, the sulfur dioxide reacts with oxygen to give us sulfur trioxide in the presence of vanadium oxide, which is used as a catalyst, and it's a contact catalyst, hence the word contact process. Then the sulfur trioxide produced there is made to dissolve in concentrated sulfuric acid to produce a compound called oleum, which is H2S2O7. This compound oleum, H2S2O7, is dissolved in water to give us sulfuric acid, H2SO4. That is how the contact process unfolds. Okay, now let's move on to ammonium phosphate. Okay, the phosphate rock is the primary source of phosphates. It is mined as fluorapatite, which is calcium 5 in brackets PO43. That's fluoro. And this is done or is mined in Phalaborwa. Okay, but this substance here is insoluble, so it cannot be absorbed by plants as is. All right. So what happened is that the phosphate rock is now reacted with sulfuric acid to form phosphoric acid, H3PO4. And this phosphoric acid then reacts with ammonia to form monoammonium phosphate, which is abbreviated MAP, or diammonium phosphate, which is DAP. Okay. Now, we have percentage content of fertilizer when we buy these fertilizers in bags. I think you have seen this. For example, if you see 3:1:4, what they are saying, that is nitrogen, that is phosphorus, that is potassium, NPK, NAPACA. All right, 3:1:4, and they tell you 32. So they tell you here 32% of that bag is these fertilizers here. Okay, so it means the remaining 68% is made up of something called fillers. Okay, these are things that help you to distribute your fertilizer evenly around, or spreading it evenly on the ground where your plants are. Okay, so in this case here, it will mean that the total parts here is 3 + 1 + 4, which is 8 parts. Okay, and if I want to get the percentage of nitrogen on that 8 parts, it will be 3 for nitrogen over 8 times 32, which will be 12%. If I want to get the percentage of phosphorus, it will be 1 over 8 total times 32, which is 4%. And if I want to get that of potassium, it will be 4 over 8 total parts multiplied by 32 equals 16%. Okay, and if you add this, you would see you're getting your 32%. 16 plus 4 is 20, plus 12 is 32%, which is the fertilizer content in your bag. But then, now the rest of the part, like I said, is made up of those things called fillers. Okay, now the rest of the bag, which is 68% here, is made up of fillers, which are used to ensure even distribution of fertilizers on the land. Now, these fillers here, are usually the following substances: is gypsum, is lime, and it's sand. Okay. Now, environmental impact of fertilizers. If we have excessive nitrogen content washed into rivers, dams, and lakes, this will cause something called eutrophication, which is a process where excessive growth of algae in water happens due to lots of nitrogen content into the water. This leads to the depletion of oxygen inside the water, leading to the death of aquatic animals, things like fish and others. Okay, so we create what we call dead zones. Okay, and over-fertilization also leads to deterioration of soil structure as humus becomes less, and also leads to soil becoming acidic, which is not good for certain types of plants. And high concentration of nitrates in drinking water leads to blue baby syndrome for little children. Okay, now that brings us to the end of the lesson, and at this point, being the last lesson for the year, I want to wish the matriculants well in their final examinations. Please go and give it your best shot. I know you can do this. We need those A's. You need to make sure you pass, and you pass well. Pass well in physical sciences, and all your doors open wide enough for you to get everything you need in your academic careers. That brings us to the end of this lesson. Thank you so much for watching. And from me, Tinyiko Kosa, it's a goodbye.